Within 45 minutes plus ads, every single crime is solved. In reality, it's really not that easy. Hello, curious people. I'm Dr. Maiken Ueland, a forensic scientist, associate professor, and director of AFTER at UTS. This is Science Curious. Let's get going. What is a body farm and what kind of research is conducted there? So a body farm, or a taphonomic facility as I like to call it, is a place where we have people who have donated their body to science, and we use these whole donated humans and study them for forensic purposes. And we do a lot of work on training police, working with forensic services, working with investigators. And at AFTER, or the Australian Facility for Taphonomic Experimental Research. And it's the only facility of its kind in Australia, in fact, in the Southern Hemisphere. Having a body farm in Australia is really critical because it means we can answer questions about cases that are in Australia or in the same environment. Because the way the body breaks down is actually really dependent on environmental parameters, like the climate, the temperature, the type of vegetation we have surrounding us, the type of scavengers, the type of insects, and these really differ across big regions. So for us, it's really important that we have AFTER here locally so that we can help with local investigations. Is forensic science anything like what we see on TV? No, is the short answer of that. There are some really good aspects of what you see on TV. They'll use the correct techniques. They might not use them the right way, but we'll see some of the techniques that we have available. But one of the things on TV that really irks me is the time since death question, where it's a really complicated to answer, but on TV, you will have the forensic pathologist or the investigator, they'll rock up in their beautiful Hummer, they'll be in a fancy suit, they'll come, they'll look at the body, check the environment, sniff the air, and go, yep, this person died Thursday at 5 p.m. sharp. That is completely unrealistic, and in reality, it's a lot more complicated. You can't really just show up and touch someone and know exactly when they died. But my least favorite is the glove use, or the misuse, I should say. They'll put gloves on, they'll touch a body, they'll touch their phone, they'll touch food with the same gloves. I would never. In the ridiculous TV world, that's the minor little things that get me. It's not the big inaccuracy in the forensics. It's more just a ridiculous use of gloves. What type of evidence do you most commonly analyze in your work? So for me, I work across the whole decomposition process. So I do particularly look at how we can find missing persons. That's one of my areas of expertise. And for that, I look at how the body is changing the environment and itself. So one of the things that I work with is actually smell. I investigate how the smell of a body is changing over time as it's breaking down, and use that to help create new technology and train things like cadaver detection dogs. And I also use tools like these guys, the drones, and looking at different imaging capabilities to help find people based on the clues that they're given off to the environment as they're breaking down. Another thing that I really work on is the time since death. And to do that, I collect tissue samples. So I look like things like lipids, which are fats in the body, how they change over time. Same with the proteins, the carbohydrates, the metabolites. So all of these really small compounds that come from your tissue samples, but they can also come from like soil samples. We take textile samples. We look at the decomposition fluid that's being released. And in all of these different sample types, we look at these biomarkers over time to try and create a timeline of change so that we can then use that timeline to say how long someone's been deceased for. How do you determine the time of death and how reliable are those methods? So when it comes to time since death, this is actually one of our trickier areas. And there's a whole range of different methods, but unfortunately a lot of them are quite subjective, meaning that you're relying on the expertise of someone and you're relying on the opinion of someone. So for example, someone like myself might be asked to look at pictures of a deceased individuals and use those images to determine how long someone's been deceased for. And this is really challenging because there are so many factors that impact the way a body breaks down. So if someone, for example, is in a hot environment or a cold environment, that's really going to change how the body is breaking down and how quickly the body is breaking down. So it's really important for us to have more objective methods. And that's something that my team is working on quite a lot, is looking at how can we develop new, more objective methods that kind of remove the expert a little bit and remove the person from the analysis and focus on more analytical approaches that can then be validated and proven, and therefore a lot more reliable. Is technology changing the field of forensic science? Absolutely. I think technology is going to have a major role to play across all fields, but also in forensic science. And we're already seeing that at it after, where we're now testing quite a lot of new technology, like drone technology, new imaging capabilities, and we're seeing a lot more use of AI as well. So for example, for our time since death question, we now have the ability to take all of the different measurements that we collect to try and understand the time since death, whether that is, the physical changes, the biomarker changes. We can look at insect trends, we can look at the environment, put it all into a model, and then leveraging AI, get a really comprehensive picture of how the decomposition progress is happening. And then use that to create timelines that are a lot more objective. So AI is definitely having a major influence across forensic science. And that's also why we're seeing the uptake of a lot more digital forensic science areas now, because a lot more of the evidence is actually online rather than physical, tangible evidence. What is the most misunderstood part of forensic science? This one, I really think, is the fact that we do everything. So a lot of people think that you become a forensic scientist, it means you're involved in every part of the investigation, you analyze all sorts of different types of evidence. When in fact, it's actually very specialized in forensics. So you become an expert on specific types of evidence, whether that's DNA, looking at chemical evidence, or like myself, who's an expert on taphonomy, so how the body breaks down. So we're actually very distinct areas of forensic scientists. And we also do not take that much part in the investigation. So we might do a very small part, but we don't oversee a whole investigation. That's being done by the detectives or the investigators. How long does it take to process a crime scene? Well, this one really is how long is a piece of string, because it's such varied. If you have a very simple crime scene, then you might be looking at a few hours. Whereas if you have complicated crime scenes or a disaster event, you might be looking at days to weeks. We also are involved in cold cases where it might have been decades since the crime was actually committed and you're coming back to process a crime scene. So it really does vary massively based on what the scenario is. What are some of the biggest challenges facing the field of forensic science today? I think one of the biggest challenges that we face in forensic science is actually the unrealistic expectations. And that stems from what I call the CSI effect and the fact that forensics is very well known because of TV and because of all the series, and people are really interested in crime. But it does mean that people think that crime can be solved very easily because that's what they see on TV and read in the books, and that's what they know. So I think that's one of the big challenges that we have in forensics, is actually getting people to understand how complicated investigations can be and how uncertain some of the evidence types might be. How do you stay objective during an investigation? This is key for any good scientist, not just a forensic scientist. And it's all about staying objective and unbiased and making sure that you're following what the data is saying rather than trying to make the data fit a narrative. And it's also really important to take emotion out of it and make sure that you're looking at your data and your results with integrity. What is your favorite crime novel? Well, I'm from Norway, so I am grown up with proper Scandinavian crime. And my favorite is Jo Nesbø and the Harry Hole series, which there's actually a TV show at the moment about that. But I think I probably read those books at a way too young of an age. Does anything ever faze or unsettle you in your work? So I am exposed to quite a lot of graphic images, which can be really confronting, especially when there's cases involving children. One particular story I had, however, was of a donor that we got coming to after. It was a young woman who had terminally ill cancer and passed away. And at the time she came into our care, we were the same age, which for me was the first instance this was happening, and it was really something that will never leave me. The fact that we had someone who was so brave, decided to donate their body to science, coming through that program at such a young age. So I, believe it or not, I actually love my job, and I love getting up in the morning knowing that I get to do what I'm doing. And it's because, although yes, I deal with a lot of difficult and challenging situations, it has such an amazing purpose. And I really get to help people at a very challenging time for their family and loved ones. That was all the questions for today. I hope you learned something new. Until next time, stay curious.